Hello everyone, myself Brunda. I am studying at Sri Venkateswara College of Engineering from the course Automata Theory and Compiler Design. Let me look over about the deterministic finite automata. The contents are introduction, definition, graphical representation of DFA, examples, applications of DFA, and finally conclusion. Introduction. DFA refers to the deterministic finite automata. Deterministic refers to the uniqueness of the computation. The finite automata are called deterministic finite automata if the machine is read an input string one symbol at a time. In DFA, there is only one path for specific input from the current state to the next state. DFA does not accept the null move. The DFA cannot change state without any input character. DFA can contain multiple final states. It is used in lexical analysis in compiler. A DFA is a collection of pi tuples, same as described. Q represents a finite set of the states like Q0, Q1, Q2, etc. The sigma represents a finite set of the input symbol, zeros and ones or A's and B's. Q0 represents the initial state, F represents the final state, and the transition function. Transition function can be defined as Q into sigma gives the Q in the DFA. Let me look over about the graphical representation of DFA. A DFA is represented by digraphs called state diagram. The vertices represent the states. The arcs labeled with an input alphabet show the transitions. The initial state is denoted by an empty single incoming arc. The final state is indicated by double circles. It is an initial state is represented with the arc and final state is represented with the double circle. Let me look over the example where the Q represents the states Q0, Q1 and the Q2, and the symbols we use zeros and ones. Q0 is the initial state and Q2 will be the final state. Let me look over about the transition table. The present state is Q0 and the final state will be the Q2. Q0 on 0 will be on the Q0 and Q0 on 1 it will go for the Q1. Q0 on 0 it will stay on the same state Q0. Q0 on 1 it will go for Q1. Q1 on 0 it will go for Q2. Q1 on 1 it will be stay in the same state Q1. Q1 on 0 it will move for Q2. Q1 on 1 it will be stay in the same state Q1. Q2 on 0 and 1 it will be stay in the same state Q2. Q2 in 0 and 1 it is stay in the same state as Q2. It is the graphical representation of DFA. Let me look over the examples. Let me look over two examples 1 and 2. The first example, the DFA with the string zeros and 1 accept all starting with 0. The string need to accept with the starting with 0. If it start with 1, it will go for the trap state. Let me look over. In the diagram, we can see that on given 0 as input to DFA in state Q0, the DFA changes state to Q1. If for the initial state Q0, if the input is 0, it will move for Q1. If the input is in 1, it will go for the trap state. It can't accept it. And always go to the final state Q1 on starting input is 0. If the input is 0, it will move for directly final state Q1. It can accept the string with 0, 0. It can accept starting with 0, 0. And if the string is start with 0 and ending with 1, if the string will start with 0, 0, 0, and if the string is start with 0, 0, 1, etc. It can't accept any string which starts with 1 because it will never go to the final state on a string starting with 1. If the string is starting with 1, it will go for the trap state Q2. Let me look over another example. DFA with the string 0 and 1 accept all ending with 0. It will accept with the string ending with 0 like 0, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 0, 0. These are the string will accept. In the above diagram, we can see that a given 0 as an input to the DFA in the state Q0, the DFA changes state to Q1. If the input for the Q0 is 0, it will move directly to the Q1. If the input is 1, it will be rotating in the Q0 until the string get the 0. It can accept the string which ends with 0 like 0, 0, 1, 0, 1, 1, 0, 1, 0, 0, etc. It can't accept any string which ends with 1. If it can't accept 1, 1, it can't accept because it will never go to the final state Q1 on one input. So the string ending with 1 will not be accepted or it will be rejected. At the Q1, if it get 1, it will back to the state Q0. Let me look over about the applications of the DFA. DFA is a mathematical model that is widely used in computer science and other fields for recognizing patterns in strings. The main advantage of DFA is that it is easy to understand and implement as the transition function is fully defined and the automaton's behavior is completely determined by its current state. Due to this property, DFA is widely used in the various applications such as language recognition. One of the most common applications of DFA is in the recognition of the formal languages. DFA can be designed to recognize a specific language such as programming language or a markup language by specifying the set of acceptable strings in the language. Compiler design. DFAs are used in the design of compilers, which are programs that translate the source code written in the programming language into the machine code. Compilers use DFA to scan the source code and identify the various tokens such as keywords and identifiers that make up the language. Text processing. TFs are used in text processing applications such as spell checkers and text editors to recognize patterns in text and perform specific actions based on those patterns. Network protocols. TFs are used in the design of network protocols such as TCP or IP to specify the sequence of events that must occur during the communication between the two devices. Lexical analysis. DFS are used in lexical analysis, which is the process of breaking down a stream of text into individual words, phrases, and other elements. Cybersecurity. DFS are used in the cybersecurity to detect and prevent malicious activities by recognizing patterns in network traffic. Pattern matching. DFA can also be used to match regular expressions in text, which is a common task in text processing and data mining. Automated testing. DFAs are also used in automated testing to check for specific input sequences and respond accordingly. Formal verification. DFA can be used in formal verification, which is the process of mathematically proving the correctness of a system or algorithm. These are the applications areas of the DFA. The DFA mainly used in the language recognition, compiler design, text processing, network protocols, lexical analysis, cybersecurity, pattern matching, automated testing, formal verification. Let me look over about the conclusion part. In conclusion, deterministic finite automata is a DFA is a theoretical construct that plays an important role in automata theory and formal language theory. DFAs are simple yet powerful tools for recognizing regular languages, which are the languages that can be generated by the regular expressions or represented by the regular grammar. This is the content of the DFA. About these are all the content of the DFA. Thank you.